Hello, it's Duncan. Regular viewers won't be surprised that I'm obsessed with the details of how long our tests are actually taking to run. I won't speak for all developers, but I at least can be a little compulsive when I get the bit between my teeth. So, when I suspected that IntelliJ was just plain lying to me about how fast tests are running, I had to see if my suspicions were true. Last week we saw that there's a lot of time between invoking the action and the test actually running. This week we'll see that the reported duration of the individual tests, and the suites they sit in, appear to be wrong too. My goodness, that is, I think, exactly what I wanted to say. In the last episode we discovered that if we run a test with the IntelliJ runner, that's this icon here, then the runner says they take 786 milliseconds to run, but in fact the test run actually took 2.1 seconds in this case, and in fact another half second before that for Gradle to decide that nothing had to be built. In contrast, let's clear that, if we run the same test in Gradle, there we go, that happened in 3.5 seconds, but the test runner thought they happened in 4.8. So I'm pretty sure that both test runners are lying to me, just different ways round, and today I'm going to seek the truth of how long our tests actually take to run. But I'm feeling lazy, so let's see whether AI system can do something for us. This one here, I think. There we go. And now I'm going to say, write a plugin for JUnit 5 that prints the actual time every test took to run. Let's have a look. Okay, so open a dialog that doesn't appear. I have seen this before, and it basically seems to mean that I need to restart IntelliJ. One moment, please. Okay then, I've rephrased that slightly different this time, but let's give it a go. This suggests we use the extension API, but in order to do that, I would have to edit every test to say extend with timing extension. So I'm going to say I don't want to use an extension on every class. I want it to load as part of JUnit. Let's try that. Okay, so this is the sort of thing I had in mind. We can have a timing extension that we register in meta-inf services and will be loaded automatically for all tests in the project. Let's use that. Create a file from the snippet. That's what I want. Let's add that to Git and then see what to do with it. Oh, it's Java. That wasn't very helpful. Let's ask AI Assistant to convert that. Could you convert the Java to Kotlin, please? Right, lots of blurb. Let's put our new Kotlin file here, which is going to be timing extension. We'll just make it a file for now. Add that. This is the text we want, so let's put that in there. And now we need to register it. So that is, say, I want a new directory here called services, new file called this thing, add, and this is your package timing extension. Let's go here, say copy reference, and we're going to put it into here, I think. Fold that away. And now let's run and see whether we get anything. There will be a little wait. Okay, really quite a long wait. What's going on? Oh, something happened. But I don't see any of the debug that I expected. I'll just check I've done as I'm told. Well, I think I've checked everything, but reading the documentation, auto detection is an advanced feature and is not enabled by default. So it looks like we need to take this thing and put it into our JUnit properties file. Let's give that a go. Paste there and try again. Look at our tests. And here we have, look. Gilded Rose Foundation property set test list value took 0 seconds, 67 milliseconds, and so on. Brilliant. Now then, look at the tests here. Take away the ignored ones. We can compare our results with the test runner's timings here. So this is property set tests. Let's go and find those. Property set tests. List value took 0. That's good. Wrong type throws, 49. Where is wrong type throws? Let's find that. Throws, there we are, 33. This says 34, so they agree quite closely. So let's go and have a look at the code of that extension. Well, that all seems quite plausible. We've got some irritating duplication here, but one thing that does stand out to me is that this is just a mutable map, and we know that we're running our tests in parallel. So I think that probably we should be using a concurrent hash map to be safe. Just check that. Well, it doesn't seem to have made things worse. Now then, this is all very interesting, but it's not very easy to visualize. What I'd actually like to see is a timeline of when every test started and stopped, so I can see how they relate to each other. To do that, instead of printing out the times when they occur, I think the best thing would be to store them and then process them at the end. Let's take this thing here and make a method out of it, which we will call name4. And yes, we want both of those, please. And for some reason, IntelliJ's got the return type wrong there. And I think, in fact, if we make this the receiver, then we could convert this to a value. Not there. No. I'm looking for convert to property, but I'm not seeing it. Well, after an annoying investigation, it turns out that convert functional to property is an intention that's not available if we're using K2 mode. So I've disabled that because why would I code with one hand behind my back? And so this is going to be to name or something. And I think what we're going to do is we're going to duplicate this and we'll say these are the end times. And take that and then that into there. Then we can put the end time in there. Get rid of that and that and that and that. And then we'll put this thing into a variable which is end time. Move that up. And our start time equals start times test name. So we're still printing here, but we're remembering the end time as well. Have a look. And do we have our output? Yes, we do. Good. Now, I want a function called when all tests are finished. So let's just ask, add a function to be called after all tests have finished. Pause for a moment and then AI assistant. Oh, well, let's say AI actions generate code. Yes, well, what I had there, AI assistant. Grrr. Well, that's nice. How do I register that function? No, not what I wanted. Never mind. Discard. Time to go off to the documentation. Okay, after a bit of research, I'm reasonably convinced that I can't do what I want to do with a JUnit extension. That is, I don't get a callback after all the tests are finished. There is, however, a test execution listener, which is a completely different API. Here's the documentation, and in fact it says here, test execution listener API is often implemented in order to produce some form of report or to display a graphical representation of the test plan in an IDE. Okay then, so let's have a look at registering a test execution listener. This says we want meta-inf services org JUnit platform launcher test execution listener. So different file name. Let's take that then. Now we're going to make our extension implement test execution listener, as well as maybe there's other things, but this doesn't exist. And then we have another episode of banging my head against documentation before I discover that's not in the standard JUnit jar files, it's in the JUnit platform launcher module, which is in a different jar file that I've got to go and find. But when I do, I can finally say that in our build.gradle.kts, we need to put something like that. Right, refresh Gradle, ask to import again. Finally we can, hooray! Now then, let's have a look at the test execution listener. This has test plan execution started, test plan execution finished, dynamic test registered, and execution skipped. And execution started, execution finished, reporting entry published. Well, I don't think it's the test plan that we want. I think it's the execution. So let's hook execution started and execution finished. Go to here, and I think now I'm going to remove these other interfaces but leave the code in place. Except that we need to remove that and that and that. Right, back to the beginning, and we're going to implement execution started with a test identifier, which I'm blithely going to assume is not null. Now what can we do with that? Test identifier dot is test, well that's handy. We've got a source, that's handy, and we've got a display name. Oh, and down here we have unique ID, either as a string or as an object. And that feels like a good thing to use for the map key. Although maybe test identifier would be. Let's have a look. Immutable data transfer object that represents a test or container part of a test plan. Let's see if it has a hash code. Oh, it does, and in fact that is the hash code of the unique ID. Splendid. So back here, and we will say that we can make our start times test identifier to long and our end times test identifier to long. And here then we're going to say start times test identifier equals that. Good. Now, execution finished. Splendid. And the same sort of thing, I think we can say end times given the test identifier, which we don't want to be null, nor that I suspect, end times test identifier equals that. Now then, we can think just get rid of these now. They're not doing anything for me. And neither are you. So we're back to simplicity. And I wonder whether we can use the test plan thing. Let's remind ourselves. This was test plan execution finished, which says all the tests have been executed. Oh, right. So let's go and do that. So this is going to be test plan execution finished. Again, I'm going to bet on that not being null. And here we're going to say start times for each. Oh, that's good. Now we're going to say end time is end times test identifier. Oh, look, it is actually completing quite reasonably. My goodness, that is, I think, exactly what I wanted to say. So, run that. Oh, there we go, look. And it looks like we have the containers for the tests, things like passing updating tests, as well as the tests inside them. So this transactions, I think, is the one inside DB items tests, for example. In fact, as DB items test is our slow one. Let's see if we can find that. DB items tests. Ooh, that's interesting, because apparently it took 1.1 seconds to execute, whereas here we're saying it only took 352 milliseconds. That lying would explain why this 855 is significantly less than the actual time the tests take to run. Okay, before we go on, and there's something of a displacement activity, millisecond resolution isn't all that great. I think I'm going to change these to be instants. That's the Java time one, and the same here. Sorry, Kotlin time. And then this is going to be instant now, as is this. And in here then we can say val duration equals duration dot between start time and the end time. And then in here we can say $duration. See what we get. And so now you can see we're getting better accuracy. We can see things down to sub-millisecond. Although, of course, that means that that isn't true. Now we know that these test identifiers form a tree. It feels like there should be one on the outside for everything, and then ones in the middle for the classes, we've seen those, and then leaves for the individual tests. To get at that, I'm going to build a model by iterating through these, and then print it rather than printing it on the way. So I think I want something like data class test stats. We've got test name. I think actually that should be the test identifier. So let's put that in there. And I don't want to do the duration yet. We can work that out. So we'll have in here val start, which is an instant, and end is an instant, and the duration, no, we will work out. Thank you. So this is going to be just called test. And now let's map those in here. So we'll take these start times, but instead of saying for each, we'll do map. And we'll map that into a test stats of the test identifier, the start time, and that thing there. Splendid. And for this, at least, I'm happy to damn it there so that we fail fast. Okay, that then means I can take end our loop there, say this is val stats, is that. What's the type of that? List of test stats, I think that's what we want. And now then we can go stats for each. We can destructure, yes, why not? So it means we can take out that and leave that and then do that. Let's have a look. And that looks good to me. Now, how to make the tree. To make the tree, we're going to have to work out the parent-child relationships. Let's remind ourselves what's in the test identifier. Here it is. Now, it would be nice if a test identifier had a parent test identifier, but it doesn't appear to. It only has a parent ID. See what we can see down here. get parent ID. So this is an optional string, and it returns a container for the unique ID of this identifier's parent. Container's confusing there. What it means is an optional for the unique ID for this parent, which is itself a container. Let's go back to our code. Okay, full disclosure, I have tried to do this with AI and sort of failed. I haven't found a way to persuade it in the right direction. What I did when I was trying to was to add the list of children here to a test stats, to give it a hint that that's what I wanted in the end. Our basic problem here is building a tree when we don't have immutable test stats. So we need to get the tree structure somehow, and I think the way to do that is before we start anything, we're going to say val grouped by parent is, and we'll go to the start times. In fact, maybe the end times, because those are the ones we know must have a start time, I suspect. I'm not sure that completion was any good. In fact, let's go back and let's give the type here to give a hint. So what we want, I think, is a map from test identifier, those are going to be the parents, to list of test identifier, those are going to be the children for those parents. Let's see whether it's got any ideas. Cell type equals. Oh no, we're on our own. So we're going to start with the end times, and we're going to go to the keys of that because those are our list of test identifiers. And we are going to take those and we're going to group them by the test identifier's parent ID object, which may be null. So let's embrace the null and we'll say get or null. Now, I think I messed this up because this thing is going to be the thing in the map, which is a parent ID object, which is a unique ID. And it may be nullable, so I think that will make it compile. So now in this map, every test identifier that doesn't have a parent will be listed under null, and every test identifier does have a parent will be listed under the unique ID of its parent, I think. So the roots of our tree, I don't know whether there's more than one or not, but val roots equals grouped by parent, null, or empty list. Oh, that was a good completion. And now we want something which is trees, which is a list of test stats. Oh, in fact, it's the thing we've got down the bottom there. And we can take our roots and map them with a function that we don't know yet, but it's something like, goodness, there's a lot of completion there. You know, maybe that will do it. Let's type tab and find out. Well, that looks plausible. Let's just find out what the issue is here. I wish it would pop up. Ah, there we are. Type inference failed. Grouped by parent, root unique ID. Well, actually, looking at this, I don't think you can ever succeed because we're only ever building a test stats here with empty list. So I'm going to say that that was nice, but I don't think it's properly recursive. So I think we're going to pretend we've got a function called create stats that takes a unique ID. And let's ask that to be brought into existence. Oh, change type of tree to list of unit. No. Create function, list test identifier map. No. Well, I'm a little confused by your suggestions there, IntelliJ. But let me just write it here as an internal function, which is something like fun create stats, which takes the test identifier and returns test stats. And for now, at least, we'll just say to do to see whether that compiles. Does it? It does, so we're on the right track. Okay then. So we want to return test identifier, test stats. It's going to have this test identifier. And my goodness, sometimes the completions are just too much. So it's going to have this test identifier. No, I just want the little one. Okay, I'll type it then. I don't know whether there's a keystroke that says complete just this one and not all the rest of that suggestions. But actually here, some of those other suggestions are reasonable because the start time for this one is going to be the start times for the test identifier and so on. So it's only this thing that I'm a little bit dubious of. And we know we can pass empty list into that for now. So this compiles. Okay, so my children given a test identifier. That looks very plausible. We go to the grouped by parent and we use our test identifier's unique ID to pick out our children. And I think the reason this isn't compiling is this unique ID here is a string, but we need the unique ID object. Okay, and once we've got our children's test identifiers, we can map create stats over those. So we can say val child stats is that. Oh, nice, thank you. And then we can put that into here. So now we should have the tree. Let's just run that to see whether it succeeds or fails. Well, the output here is still this output here, but nothing blew up, which is a start. Okay then, so how do we print a tree? Well, as with creating one, we normally use a recursive function. So let's build ourselves a thing that says fun print tree. Again, the AI is quite smart. It says take some test stats and a depth, which is pretty much what we want. And goodness me, well, that's very close, isn't it? So what this is saying is, I'll type tab. We want to print an indent, which is a space repeated for the depth, then the display name, and then go through each one of our children and print those, adding one to the depth. Only thing I might do, I think, is make it 2 spaces. Note that we need a named function here because it calls itself. And so now I think we should be able to say, we've built the trees here, and we should be able to say print tree given my trees. Do I want to do first because I think there's only one root? No, let's do it the other way. Let's say trees for each print line, but no, we want to do print tree it. If we're right, we won't need these, but I will keep this code here so we remember how to find the duration. Let's have a look. Oh, there we go, look. Passes updating tests, has increases in quality, and so yes, these are our test suites. These are the functions within the test suites that define the tests themselves. And if we go all the way up to the top, maybe we have one root, which is JUnit Jupyter, which I think is the equivalent of this thing here. Splendid. Okay then, let's put in the duration. I think the sensible thing to do is to add it to test stats as a method. So let's put these on separate lines, and then we'll say, well, in fact, it can be a property, can't it? We'll say val duration is Java time duration between, ooh, yes, thank you. And now we can take that and put it in here. So let's add a space and test stats duration. That would allow us to get rid of that and run. Good. I'm just going to turn the test runner plugin back on and run that again, so that we can now see that the plugin thinks that the test runner took 2.1 seconds. Let's have a look. So 2.1 seconds actual process runtime, 680 declared here, but at the top of our list, we think the total was 1.1 seconds. Now the process runtime is going to include startup and all that sort of stuff, but it seems to me that this is seriously underreporting the time that it takes to run the tests. Now dbItems test apparently here is taking 301 milliseconds. That's the slowest test. That's why we're starting to run it first and in parallel. Let's see where that is in here. dbItems tests. Here we go. And the test runner here says it takes 300 milliseconds, but this says that it takes 1.1 seconds in total. Goodness. Now, given that our entire test run took about 1.1 seconds, and we started dbItems tests first, you can see then that the entire length of our test run is pretty much running dbItems tests. And if we build the child states here, we then sort by it.end and run that. Have a look. Yes, indeed, here now you can see that dbItems test is the last test to end, and it was the first test to run. This time it took 1.5 seconds. We can probably confirm that if we go to dbItems tests and just ignore it, disable and rerun. Now, in fact, our test is still taking 1.6 seconds as a process, 684 milliseconds according to IntelliJ's runner. But we think that the total is, well, interestingly, we think, in fact, that it was quicker now than IntelliJ is telling us. Now, small differences may be because we are measuring the instrumentation that IntelliJ adds, or it may be that IntelliJ is measuring the instrumentation that we've just added. Who knows? But even looking here, there are some big discrepancies. So days 2 tests, IntelliJ says took 12 milliseconds, of which 11 was daylight saving time and practically nothing else, whereas we see it taking 55 milliseconds. So definitely some more investigations to be done. And I think those investigations would be easier with a proper diagram rather than this text output. So we'll look at that next time. Just before we go, let's have a little tidy up. We'll put that back, go back to timing extension. I think that this thing is a function. So we'll make that a method, which is extract stats, and print tree we will promote to a method at the top level, I think. And in fact, that I think doesn't depend on any of the test state. So we make that private. This extract stats does require test state, so we'll leave it there. We'll inline that, leave that, inline that. Ooh, that's a bit ugly. What are we doing? We're saying empty list. We're saying if this is null, it's an empty list, and then map on it. I think we could take that out of there, make that a question mark, pull the else empty list to the top, and get rid of that bracket, that bracket. So we're going to find that, then we're going to do that and that, or that. Take you out, and then our test plan execution finish is just saying extract the stats and then print them. I think we might reasonably remove that. And then in fact even inline that to tighten things up. Run. Check what we've got. Still looks plausible. DB items test is still taking 1.2 seconds rather than 340 milliseconds, which we can make our New Year's resolution to investigate. Well, I hope you enjoyed that as much as I did. If you did, then please press like on the video. If you want to see the next one, in which we'll look at building a visualization of these test results, have a feeling that Mermaid is swimming in this direction, then please subscribe to the channel. If you'd like hands-on training, then Nat Price and I are running a workshop at Kotlin Conf in May that you could sign up for. And finally, don't forget to tell Santa that you want a copy of Java to Kotlin Refactoring Guidebook, details of which are in the show notes below. Thanks for watching.